Okay, so yesterday we talked about, or we actually wrote down the reaction types, but we didn't talk about them. So today we're going to talk about them, and we're going to review our baby stoichiometry from Chem 1 before we get into the harder things. So we'll talk about reaction types first. The first type of reaction is called a synthesis. This is the simplest type, synthesis or combination. And depending upon what chemistry book you're looking in, it'll call it one or the other. I don't even know which one your book calls it for sure. A combination reaction or a synthesis reaction is when you start with two components or two substances, and you end with one. So you know how in math and science we always love having algebraic expressions of things or equations that go with things. We have algebraic equations that go with the types of chemical reactions or chemical equations, and they're really easy to understand. This one would look like A plus B yields AB, or sometimes you'll see X plus Y yields XY. So they're pretty straightforward. You just put them together. The flip side of a synthesis or combination reaction is called a decomposition reaction. And this is the opposite. Start with one, and you end with two or more. Kind of have to figure it out from what you start with. A lot of times these are reactions that have water and hydroxide involved. If you have hydroxide on one side, on the other side of the equation you're either going to get oxygen gas, hydrogen gas, or you're going to get water. And you just have to think it through and try to figure out which one you're going to get. Because sometimes if you have OH on one side, sometimes on your product side you'll get something with the ion oxide, like iron oxide plus hydrogen gas if you had OH on the other side. So you just have to, it'll come. The more we practice it, it'll make sense. But it's kind of like a puzzle, just figuring out the pieces of the puzzle. Oh, did we write down? I did not. So let's write this down. XY, I would show on this side as X plus Y, or I had AB. So I would show as A plus B. All right, the third type is called a single replacement reaction. And that is where at the start you have a compound and an element, or something in elemental form. In the end, you have a new compound and a new free element. So compound plus element, new compound, new element. So it might look like this. XY plus Z, and on the other side of the equation I would have XZ plus Y. Make sense? All right. Next type is called a double replacement. Reaction. And you start with two compounds. And on the other side of the equation, you get two new compounds. Start with 2, end with 2. So, XY plus WZ yields. And let's think about this, because a lot of times these are ionic compounds that you're dealing with. So if this XY is an ionic compound, what's the charge on the X? Yeah, this would be my positive, this would be my negative. If this is an ionic compound, my W would be my positive, and my Z would be my negative. So, the double replacement are one of the easiest ones to predict the other side of the equation, because your cation on this compound hooks up with your anion over here, and your cation from this compound hooks up with this anion. Now, do you have to balance charges so you have a neutral compound? Yes. You can't just carry over the number associated with them. You have to make sure it's neutral. So I would have XZ plus Y, oops, I wrote that backwards, WY on this side. Got to write my cation first. Positive always comes first. Okay? And the last one, these are the most fun. It's called a combustion reaction. Combustion reaction, these are the reactions where, like, you had a couple of them on that paper the other day, or yesterday. It was the one where I said when you have these odd numbers on this side, lots of times you have to double things and then balance your oxygen. There's not an algebraic equation for this. You start with a hydrocarbon plus oxygen gas, and you get carbon dioxide and water, always. There's no other pattern for these. So what do you got to look for? You have to look for a CH compound in some form. Doesn't matter what the subscripts are, it's always a C and an H plus O2. And then on the other side, you're going to get CO2 and H2O. They're the easiest ones to predict because the products are always the same thing. They're the hardest ones to balance, probably, if it's a big one. Okay. Now, we're going to stop for a minute, and I want you to pull that paper out from yesterday. Fletch, do you need a paper? Okay. Let me find my folder. I put some in there. There it is. Maybe. Nope. That's not it. Where did I put that folder? I don't have enough of them. Yep. Okay, so now what I want you to do, I want you to break into lab groups, and I want you to take that paper and I want you to go through and I want you to label them with reaction type. If you weren't here yesterday, you need to balance those equations. And if you weren't here yesterday, I put the notes on Classroom for you.